Okay, now we'll consider some idea about how it will come when you are plotting these interpolations by using any Python or any other programs. So we will consider the output of the plotting with polynomial, linear, and splines, all those techniques, and we'll check how it is different from each other. So let's say this is our original data, this one. So this one is our original data, and we have the value which is changing from -1 to +1. For up to some 3.6 we have -1, and then we have from 4 onwards we have different, that is +1 values. So this is our original graph which is represented by this black color. So this is the original curve. So now we have to check how it will be when we are using some polynomial or other spline interpolation, and how it will be looking like. So first we consider the linear interpolation first for this same technique. So for the case of linear interpolation, we have the first case. So we have this y-axis here, and this is our x-axis, and we can see from this curve, this is linear spline linear fitting, which is spline linear interpolation. So for linear interpolation, we can see that this is not that much accurate with the original curve. Like as you can see from here, this curve is having some different kind of shape in this region, because it is just connecting those 2 points through linear interpolation. So we have some almost some kind of sloppy nature in that curve. So that is not that much accurate with the original data at this region. Okay, so that is the linear interpolation technique. If you are using linear interpolation technique, you use for interpolation, then for this particular curve, then we can have this kind of interpolation. So that is not that much accurate in between this 3 and 4 point. But when you are considering this case, so here we are considering this is our y and this is x, then we are considering here is the cubic spline interpolation. For the case of cubic spline interpolation, we have a curve like this. So this is much more accurate into in this region. You can see that it is much more accurate to the original curve than the linear interpolation. This is more accurate. So this is corresponding to the cubic spline interpolation. So we have to consider x to the power cube of order here, and in each it will be fitting in each of these between each of these lines, these points. Each of these points we have splines, different splines, and it is almost similar to the original curve. So let's look at the polynomial interpolation. So in polynomial interpolation, we have some higher degree polynomial, for example 5 or 6 degree. This is 5 degree polynomial. So we can see from here it is having a very oscillatory behavior, and it is very much different from the original data. So we can also see from this endpoints we have very large difference in our original values from our original values. So we cannot have that much of pretty good interpolation with the polynomial interpolation. So this is the polynomial interpolation. So these are just representation to show you how it will be looking like if you are using different kind of interpolation for same set of data. So we can understand that this spline interpolation with cubic is more accurate than any other interpolation technique that we have considered here, which is much better than polynomial, which is better than linear, and it will be better than the quadratic if you are using cubic also. So that is also there. So we didn't discuss about the quadratic case, but this is a cubic case which is more accurate towards your the original data. And one more graph we will consider. Suppose this is another set of data we have, and this is the original curve which is in the brown color or gray color, whatever it is. So then we consider here, suppose if you consider the linear interpolation here, then we can draw linear interpolation like this. Between these points, the linear interpolation will be like this. So okay, so it will be almost like this, and again come back. Okay, so this will be your linear interpolation. This in green color, this is your linear interpolation, and this brown color, which is your original function, that is the sine function, sine of x. And then if you consider the same case for the quadratic interpolation, let's say, and in the case of quadratic interpolation, quadratic spline interpolation, we will get much more accurate curve. For example, if you are considering the same kind for quadratic, then we will get like this. So that one will be more accurate to the original curve than the linear interpolation. So this red color which is shown here is the quadratic interpolation, quadratic spline interpolation. Okay, so this is your quadratic spline interpolation. So it will be much more accurate to your original value, original function. So from here we can see that the linear, if you are using linear interpolation technique, then the linear interpolation technique is having some kind of non-fitting behavior in this region, and you can also see a very different kind of slope, or this point is we cannot having any derivative, so we have a discontinuous slope in this region. So these are the limitations with the linear interpolation technique, but this we cannot see any such kind of thing when you are using the quadratic spline interpolation, and if you use cubic spline interpolation, then it will be much more accurate. So this is the basic idea of using spline interpolation. So how it is going to be affect your the graph or the interpolation when it comes to the your plotting, if you are plotting for different interpolations. So this is just a very short idea behind how it will be looking like when you are plotting this interpolation with the different softwares. Okay.